Okay, so let's take a look at what are known as slant asymptotes, and we're going to have to bring a little bit of calculus concepts into this, so we'll talk about it a little bit. So the first thing that you need to make sure that we do when we're dealing with slant asymptotes is make sure everything is in standard form, right? So I'm just going to factor this one out into x squared minus 10x plus 21, all divided by negative x plus 2. Okay, now you could use polynomial long division, right? But I like to use synthetic division. Now, in order to use synthetic division, this negative is a problem. You can't have a negative x. So what I'm going to do is I'm going to move it up to the top. And how I'm going to do that is I'm just going to change the signs of everything, right? So negative x squared plus 10x minus 21, all divided by x minus 2. And what that does is now I can use synthetic division, right? Because I know that this is the root, 2 is the root, and then let's use synthetic division because it's really quick. So I've got a negative 1 here, I've got a positive 10 here, and a negative 21 here, all right? So the rule is bring down that, multiply. 2 times negative 1 is negative 2. Push those together, so 10 minus 2 is 8. 2 times 8 is 16. And then I'm left with negative 21 plus 16 is negative 5. Now that's the remainder, that's the constant, and that is x. So what we're left with here is negative x plus 8, and we have a remainder now. So it's negative 5 divided by the original factor, which is x minus 2. Okay, now here's where the calculus kind of comes into play. As x approaches infinity or negative infinity, let's say, for example, that means think about putting in 1,000,000 into this number. Like, what if we put a very large number in right here? Okay, what does this become? This number becomes minus 5 over 999,998. Okay, for example. So really, this number is very close to 0. Okay. So what that means, as we get closer to infinity, this really, if you think about it, this is really just like the number 0. So what that leaves us with is this equation, right? This is a factored equation. And what that turns out to be is the line y equals negative x plus 8. And that's what's called a slant asymptote, all right? That's what's called a slant asymptote, right? So what exactly do we mean by that? That means if we put this rational function into our calculator, I'll show you, all right? If we go to our calculator right here, I'm going to turn off the asymptote right now, but I'm just going to put the function into our calculator. And if we go ahead and look at the graph, we can see we've got a vertical asymptote at 2, right? Okay, but you can see as we kind of zoom out here, it kind of forms the shape of the line, right? And what that is this line right here. I'll turn it on right now. So go back to the graph. There it is. Right, you can see that this function will forever get close and close and close. But if I zoom in, right, if I zoom in, as look, I'm just traveling left, it'll never touch that red line, right? And that's what's called a slant asymptote. Now you can have slant asymptote and slant quadratics and slant cubics as you get more and more complex, right? But the easiest way to do that, so just to review, is if we go ahead, is first write it in standard form, okay? So you can see that I wrote the function here in standard form, all right? Next step is get our denominator into a positive x value so we can use synthetic division, okay? If you want to just go from here in long division, great, that's fine by all means. I think this is just a more efficient way, all right? And now, once we calculate our synthetic division, this is going to be our factor. And now what happens here, this factor right here becomes irrelevant because as we put very, very, very large numbers in here, this really just kind of gets close to 0, right? So what's left over is the equation of our slant asymptote, okay? All right, aspire to do, good luck.